This video recreates the session delivered at Tech Exchange 2025 on IBM Fusion for Bare Metal OpenShift within an air-gapped data center. It's intended for anyone preparing to deploy Fusion 8CI in a fully isolated environment. The session covers the architecture, what worked well, and the areas that need refinement, with practical guidance drawn directly from a real deployment. It follows our journey from first principles to a fully operational environment. Here's how it unfolds. First, I'll set the scene, why this deployment had to be fully air-gapped, and how strict security requirements influenced every decision we made. Then, we'll dive into the architecture, exploring key design decisions that shaped the platform. After that, we'll focus on the registry. In an air-gapped world, it's not just a service, it's your lifeline. From there, we'll shift our focus to the deployment and configuration of platform services. And finally, we'll talk about operations, from support to managing the platform lifecycle. At each step, I'll share what worked, what didn't, and what I'd do differently. Defense's mission remains constant, clear, unwavering, and essential to the nation. But what does it take to deliver on that? Defense is one of the nation's largest and most complex organizations, with over 100,000 personnel and an operating budget that represents 2% of the nation's GDP. With that scale comes enormous responsibility. Defense isn't just about warfighting. It's also about safeguarding information and maintaining readiness, where the stakes are nothing less than national security. And that's why, for us, security isn't a feature, it's the foundation. Every system and every process has to live up to that mission. We deployed the platform inside a high-security, air-gapped data center, an environment completely isolated from the outside world, where every action is tightly controlled. Security is never a single barrier. It's layer upon layer, each designed to slow, stop, and detect. This is defense in depth. No one control is enough on its own, but together they make compromise extremely difficult. It begins with people, Australian citizens who undergo comprehensive background checks, followed by ongoing vetting. Recognizing that insider threats remain a serious risk. Next is multi-factor authentication, such as passwords, physical tokens, and biometrics. Device control adds another layer. Every component must be sourced through approved supply chains, verified and validated before it ever reaches the site. Within secure areas, only approved encrypted devices are permitted. And finally, physical safeguards reinforce the digital controls, with zone-by-zone approvals that strictly regulate who crosses each boundary. Unlike commercial settings, change is costly. You can't just swap a device or update an access list. Each adjustment demands careful consideration and approvals. Change is measured in months, not days, and sometimes it isn't possible at all. That's why detailed planning is everything. Picture this. You're at a dark site. No internet, no external devices. And yet, you're expected to deliver an agile platform that is resilient and secure. This was the challenge we faced. Air-gapped and cloud-native, we have been conditioned by the convenience of connected environments. The ability to pull images from public registries and iterate rapidly. At a dark site, none of those assumptions hold true. Instead, every patch and every update has to be moved through secure pipelines. In this session, I'll take you through the deployment of the DS Lab platform. The D and the S in DS Lab is multifaceted. It represents how our team integrates systems, transforms data, and presents actionable insights to decision makers. Our platform delivers predictive capabilities for defense that reduce cost, optimize resource utilization, and help maintain readiness. I can share our approach and architectural principles, but the delivered solutions remain classified. This platform is just one element within Defense's vast analytics network. but it shows how modern approaches can succeed in the most constrained environments.